Welcome to another RDWorks Learning Lab. Today we're going to try and combine two projects into one. Now, for a long time I've been wanting to get back onto something that I did a long time ago. I manufactured a jig for holding a glass, which is a tapered glass, into a horizontal position for etching. As a design exercise, it was a success. As a design, it was a bit of a failure. It didn't work very well at all. And I've been promising to go back and do the job properly. But I never have, because I've been distracted on too many other things, more important things. But now I've taken a few moments to redesign it completely. The DXF files will be available for this project. We've got some 5mm material in the middle, and we've got two pieces of thinner material. It doesn't matter what thickness they are. These happen to be about 2mm thick, but they could be 1.5 or they could be 3mm. It really doesn't matter. But the idea is that this piece fits snugly over that piece there. And why have I done that? Well, because I need to be able to put this piece here underneath my rotary attachment. I've designed it very carefully with these pieces here so that it either fits inside that narrow roller or outside. Before we do any more, we need to build on this piece here. So what I've got is some eccentric wheels, which I'm going to put an M5 screw through. It's got a spacing washer behind it, and it passes through one of the holes there. And then there's a nylock nut that goes on the back. Now, it's important that you use a nylock nut because we want to put some tension on these, and we want to keep the tension on them. So we put some tension on there so that we can rotate them, but only just. Okay, so they're stiff to rotate. Okay. We've got this little lever here, and in one side I've put a countersunk hole so that I can put an M3 countersunk screw in there, and it sits flush with the surface. So we've got a shake-proof washer on there and an M3 nut. And we just lock the screw so that it's nice and solid in that lever. Now we put these two little wheels on here, and again we've got a nylock nut, an M3 nylock nut. What we're trying to do is just take most of the slack out of there so that they still rotate nice and freely. And then what we should be able to do is, on the same side as these wheels, we're going to slide this piece. It runs up and down between here as a guide. And then we've got a thumb screw. I've already tapped a hole in here, which is an M5 tapped hole. And then I've got an M5 thumb screw so that I can adjust that up and down and lock it in any position. Okay, well, let's leave it down at the moment and loose. Just to pop this on top of here. And it should snuggle on the top there nicely. And now what we can do is to put our glass in, and our glass will touch on this edge here. Now, I might possibly make a further modification to this design to include a little roller, a little vertical roller that's like an end stop, but it seems to move fairly smoothly on there without too much resistance and friction, so maybe I'll just leave it as it is and I'll use the frame as the end stop. But now what we've got to do is to lift. First of all, we've got to move these wheels so that we can get the glass in between the wheels. Okay, now what we're going to do is we're now going to lift the glass up until this surface here is horizontal. And that's not far off, but we'll go just a little bit more. Let me have a look at it from the side. This is a funny shaped glass, so it's a bit difficult to... There we go. So that's about horizontal just for that section there, and then it goes into a funny curved shape. But the problem now is it's wobbling around at the back, and that's what these wheels are for. These wheels are on here so that we can take the slack out of the back but still leave it sitting on the rollers. Now we must make sure that there's just the merest amount of clearance in there. Just adjust these wheels just a bit too much. There we go. And now what it's doing, it's rotating on the wheel at the back here, and this is stopping it from falling from side to side. And I've now pushed that forward, and I might have to put a weight or something on there, or some rubber feet on here to stop this possibly creeping backwards. I don't think it will, but even if it does, then I can just, as I said, put some rubber feet on there or something to stop it from moving. The problem that we now have is making sure that we get a good drive on here, because this glass is quite heavy, and as you can see it does slide round on the rollers, and so once it gets some inertia going it possibly might tend to wiggle and jump around out of position. So how do I solve that problem? Well, it's very simple. Some people put O-rings on here which changes the ratios quite significantly. All I do is just round the end of the glass like that, I put a rubber band. That's possibly more stable in the other position, so let's try it in the other position. And all we've got to do is just remove our top like that and slide it back again. But we shall have to set the system up again because it's setting so much lower. And that's a lot more stable. That'll drive well. Now just a quick reminder, when you install your rotary table, the chances are that you'll probably have to put your stepper motor over to the back right hand corner. That will be the correct orientation for the table. Now just up here is the plug for the Y-axis, which we've got to disconnect, and we've got to reconnect this plug back in its place. But we don't do that with the machine switched on. But before you switch the machine off, make sure that you've got your table sufficiently low to clear everything. You don't want any chance of the head smashing into anything. It shouldn't technically, because we're going to disable disable this axis. But of course, depending on where your datum was before, if it was in the middle here, when you go to find your start position, it could possibly come back right to the middle here and clash with something. So just be sure by dropping the table down. So I'm now going to switch the machine off, and now I can disconnect my Y-axis. We'll tuck that plug safely out the way somewhere, because it's not going to get caught there, because this axis is now free. I can move it backwards and forwards with my hand. I can do the same with this one as well, but we're not going to, because that will continue to be driven. So we'll plug this in. We'll just make sure that the cables are tucked well out the way. And we turn the machine back on. Now the first thing that's going to happen is this head is going to run to the left. and these rollers are going to carry on working because the machine thinks it's gradually driving this towards the stop. So you should be able to just push it to the back of the machine. The system hasn't reset, so we should pull it forward a little bit. And now the system has reset. Remember what I said? The 0 might be in the middle here. And sure enough, it is. So as you can see, we can drive the x-axis backwards and forwards, left to right. But when we press the up and down arrows, we're now rotating these. Okay, we've got lots of lovely free test pieces here. But one of the problems with it is, as you can see, it's got a tendency to slide very easily. And the way that I'm going to overcome that is I'm going to put a couple of elastic bands around it. Just make sure they're not twisted. There we go. They don't have to be on perfectly, they just have to be flat, basically. Right. Now it doesn't slip. So when I rotate it, yeah, you see that's one of the problems of setting to the central position. I'm no longer at the top left hand corner. That's why I couldn't drive this to one end of the stroke. I've had to drive it somewhere towards the middle of the stroke so that there's room for it to work either side of the program datum. So let's give it a try and we'll see what results we get. Just see what the distance is. It's just a little bit too close. It's about right. Okay, the other thing I notice is whenever you set the head to a central position, it always engraves from the bottom to the top, whereas when you have it set in the top left hand corner, it engraves from the top to the bottom. An interesting thing to remember if you want to specifically engrave in one direction. Now let's have a look at the result. Normally when you do engraving on glass, the last thing you want to do is to touch the job, because there's all sorts of little shards of glass all over the place. And there is just a little bit of a hint of that just around the edge, and I'm being very careful how I touch it. But in fact that doesn't feel too bad at all. Okay, well we're doing something else now. Now various people have suggested different things to make the cut better. One of them is to put some washing up liquid in the cut area. So and let's run it again. I must say I'm very pleased with this high frequency impact engraving. It produces almost a bead blast effect. It's very fine and yeah, uniform. Again, very carefully I'm going to feel and I have to say that is not quite, there's still one or two little teeny weeny shards right round the edge of the job, but in general that feels quite nice. There's certainly not much in the way of little micro shards there. I'm quite happy to rub my finger around that, whereas I'm not happy to necessarily do the same around the edge of that one. Now, a very kind individual in the States has sent me a free sample of LMC 6044 Cermark. Now this is a special material for supposedly marking tiles and ceramics, glass as well I'm presuming, so I'm going to see whether or not this works on our glass sample here. So if it's anything like the previous stuff which you use for marking metal, you have to let it dry. Let's see if I can get it less blotchy. Try a little bit of assistance. Well, that didn't take long to dry. And let's see what we do this time. I'm not going to change anything, I'm just going to leave the settings the same. Okay. In places it has marked it darker, but obviously I need a much more uniform coat, and I can feel that it is sticking to the surface this time. Where it was thin round there, it's not stuck to the surface. It's coloured it and it's made it a lot more distinct, but round here where it was a little bit thicker, it has started to cake up and coat to the surface. But it does scrape off. But it has done a good job of filling in the holes there, and as you can see, it's definitely coloured it. If I could get it uniformly, probably spray it on with a little air gun, it would probably come out quite nice. I'm not going to do much more with that, but that is, I'm going to experiment with that at a later date. But that is that's Cermark. Well, while we're in the mood for doing one or two silly things, let's just try this. Now I'm still running at 13% here, 300 millimeters a second. And by the time I've cleaned it down, I don't think there's any difference between that and soap. And what was that? It might work on stainless steel, it might even work on brass, which we haven't tried, but it certainly doesn't work on glass. I think you can see this one here, which is with the molybdenum disulfide, is actually a better defined etch than this one. So maybe it is doing just a little something. It's helping to clearly define. It makes it look much more like bead blasting than this one. And this one is definitely still rough, and this one is really smooth. So maybe there is an advantage to using molybdenum disulfide. Not something I expected. Yeah, I can definitely feel this is rough and this one is smooth. Well, we've got our jig installed on the fixture now, and we've got our rubber band around the mouth here. We'll drop that into the fixture so you can see that that end is definitely low, and we'll raise the table up we'll move the head along towards this high end, we'll move the head out the way, bring the table up a little bit, and little by little we'll find approximately the high point. Now that's nearly there, look, that's within about half a millimetre or a millimetre. So we'll now go to the other end, which is the low end, and we now raise this up until it touches the nozzle. Well, we've got this top surface horizontal. Now what we've got to do now is to stop the glass from flopping around sideways, and we'll do that by gradually just winding our wheels in very slightly. Like that, and then we'll test that everything's working okay. We'll go roughly to the middle of the stroke. Let's find out where that is. So we just wind it into a clear area. because we know that we're going to start at the bottom of our logo. We'll put this into the middle of the glass where we want the logo to be, about there somewhere. Let's bear in mind how successful this stuff was. And I suggest that you practice like I did on some preserve jars, because they're cheap, they're free, you throw them away normally. I don't now, I tend to collect a few. Well, that was just a quick dirty test to show you how the Rotary device works. If you're interested in making one for yourself, the DXF files will be available.